Hello everyone, and welcome to my partial fraction decomposition lesson. Alright, so first we have 9x minus 7 over 2x squared minus 3x plus 1. So the first step we have to do is to factor it, factor the denominator, I mean. So I'm going to write it up here, minus 3x plus 1. So this is the denominator, we just wrote it up here. And we want to factor this. So to do that, we know we have 2x squared here. So we know first that the x squared has to be on both sides. X and x. Right? And then because it's 2x squared, the 2 has to be somewhere. So the 2 is right there. Right? So that's the beginning of this term. And this is another one right here. Okay, so next we know that this right here is a negative number. So because it's negative, we have to, these have to be negative as well. So this is a minus sign right here. So minus, and this last number is positive 1, which also means these have to be negative. So because these will multiply and make this positive 1. So negative 1 and minus 1. So these are our two factors. Alright, so now with our two factors, we have 2x minus 1 and x minus 1. So now what we do, let me write it over here so there's more space. So 2x minus 1 and x minus 1. So these are the two factors from right here. So what we want to do, we want to put it over a plus b. So then now this will be like the decomposed part right here. So now we want to get common denominators. So to do that, we need the special form of 1. So this needs to be multiplied over to this side. So we would use a special form of 1, which is 2x minus 1 over 2x minus 1. So then this right here is basically a 1. So when we multiply that, we'll have the, oh, we also need to do it to this side too. So we're gonna multiply this on this side. Hopefully you can see that. It's on the red line. That's a 1. Okay, so now with this, we will just rewrite it over here. So that will make it a times x minus 1, right? And then for b, it's almost the same. Whoops, wrote it too close. Okay, so these are the special form of 1 that we multiplied it by. So then now these two common denominators are the same, so we don't have to write them like this. We can combine them together. So what that looks like, it will be and then we'll put it all, put it all over this same denominator, because we got the, we found it, the common denominator. Alright, so there we go. So now that we have this, the next step is to multiply the numerator. So this will basically look like, yeah, let's write it here. It'll look like this. A, because we're multiplying the A with x minus 1, and B is going to be multiplied by 2x minus 1, so minus sign. So that's what I'm doing right now. So plus b, 2bx, sorry, 2bx minus b. This is all over the same denominator. Okay, so now that we have this, we are almost done. So, oh, you have to remember that this is still equal to this. So that's what I'm gonna do. I'm gonna write it out. Right, I'm gonna write it here, 9x minus 7. This is the original problem. So I'm just rewriting it here. And then this is equal to what we had right here. So I'm gonna rewrite it. Okay. And then the same thing, same common denominator. Right. So from here we need to have like our formula for our matrix that we're gonna, that we're gonna be making later. So to do that, we are going to write the numerator. We're going to write it out. So let me write it right here. Ax minus a, right? Same thing. Plus 2bx minus b, and then equals this because they do equal. So 9x minus 7. So now we need to separate it, and what I mean by separate it is we're going to have all the a's in a column. So since it's ax, we want this one right here, we want it to be on the top row, and we don't write out the x. So basically any like a letter A, B, C that has x will be on the top row, and the letter A, B, C will be its own column. So I'll write it out. So what that means, so we have ax, so we don't write the x, it'll just be a, and then we have 2bx, so that'd be plus 2b, and then our first one, because it has the x, it'll equal 9. Right, so that's the first step. So we have these all in one row, and we do the same thing for this one right here. So you see we have all these. So this, because they're all negative, we can make it positive. So it would be a plus b. See, b. I just turn them all positive because they're all negative, and then this will equal 7. So this is basically the foundation for our matrices. So we can use this for our matrix, and we're just using this. So since it's A by itself, that's 1. So for our matrix, it'll look like this, we're using the coefficient of the variables, so since there is no other number here, it's 1. So like this one would be 1, and then it would be positive 2, and then 9. So then for the bottom, it would be 1, positive 1, and then 7. So this is our matrix, and we are halfway done. I just moved to a separate sheet of paper, and now that we have our matrix, we have to make it into the reduced row echelon form. It's a fancy name, but it's reduced row echelon form. I think that's how you pronounce it. ECHELON. So what that looks like is basically having all the ones going diagonally and then zeros in every other spot. So and then whatever it equals here, so it can be something random. So what we're basically doing is making it a bunch of ones and zeros, but the ones run diagonally and the zeros will fill up the rest of the spots. So that's what we're going to be doing here. So we need 1 here, and then zeros to fill in the extra remaining slots. So that's what we're going to do. So now to do that, to make the reduced row echelon form, so what we're going to do, we need to use functions to make the zeros and the ones where they're supposed to be. So first we want to make this one a 0. Well, first we were supposed to make this a 1, but since it's already a 1, it's good. So with our pivot here, we need to make this a 0. So to do that, we can let me write it here. Dang it. We can subtract, right? So we can subtract row 1 and then add it, so it'll be plus, can add it to row 2. So what that basically looks like, so we'll have minus row 1, so basically negative row 1, so negative 1 and then negative 2, negative 9, right? So this is row 1, right? We'll write that right here, row 1. So it's negative row 1, and we will add it. So we're adding this to row 2. Row 2, so row 2 is 1, 1, 7. So then we add it. So that'd be 0, this would be negative 1, and this would be negative 2. Right, so now since we were solving for this bottom row, we use this and we replace it with the bottom row, but the top row stays the same. So what this will look like, let me write it down here. So what this will basically look like, the top row, row 1, will remain the same. So, and then the bottom row, which is what we found here, this will be our new row 2. So like that. So now we have our pivot here, 1, and we have our first 0 underneath. So now what we have to do is we have to make this a 0 and this a positive 1, and then we'll have our answer right here. So the next step, we need to do the same thing, use a function and get this to be a 0 and then this to be a positive 1. So to do that, we can multiply, right? So this is what we're gonna do. So we can multiply 2 times row 2. We put row 2 in first because we are going to be changing row 1. So 2 times row 2 plus row 1. Alright, so what this looks like, 0, -2, -4, plus row 1. So that is the same row 1 from this one. So it would be 1, 2, 9. Alright, so we add them together. And this is what we get. So this will be our new row 1. So that's what we'll write it as. Get a new row 1. So this is over here. This will be our new row 1. So look like this. 1, 0, 5, and we have 0, -1, -2. So this went right here. So you can already see what the next step would be, which would be just to negative row, like multiply it by -1. So negative R2, which basically swaps this, makes this positive. And then we will have our answer. 0, 1, and +2. So there we go. We have our answer right here. And of course, we can't leave it like this. So right here, this is basically our answer, 5 and 2. So what we do, we go all the way back to the beginning, right, where we had A and B. So I'm gonna write it out here, but actually let's go back. We'll go back, and right here where we had A and B, so we would basically write it again, but this time it'll look like this. So we have the 9x minus 7 over, so this is the original problem, over 2x squared minus 3x plus 1 equals, so instead of the A and B and then the stuff that we factored in, so right here, no, this one, so right here on how we have our factors, this is what we're doing, but instead the A and the B are the 5 and the 2 that we got earlier. So it will look like this. We have our first factored term that we made over there, which would be 2x minus 1, and then we'll put 5 and then plus 2x minus 1. So this is our final answer right here, this whole thing. So this is our final answer.